In chapters 4 and 5, we talked about looking at relationships between two quantitative variables. And when we moved on to chapter 6, we started talking about relationships between two categorical variables. And really, up to this point, we haven't talked a lot about categorical variables other than talking about bar charts and pie charts back in chapter 1. So our method for examining data for this categorical data is first to look at each variable individually by looking at a marginal distribution, and then to look at the relationship between the variables by looking at conditional distributions. So here I have a two-way table. This data says it's the popularity of computer, video, online, and virtual reality games has raised concerns about their ability to negatively affect youth. The data below are based on a recent survey of 14 to 18-year-olds in Connecticut high schools. Here's the two-way table. It says, what is the marginal distribution for grade average? So before we can start calculating marginal or conditional distributions, we're going to need to calculate the row and column totals for this table. So I'm going to start by adding across the columns. So if I take 736 plus 205, that gives me 941. 450 plus 144 is 594. And 193 plus 80 is 273. I'm going to do the same thing the other direction across the rows, and I get 1379 for the first row. If I add those numbers up and adding the second row, I get 429. And if I add up all the numbers in the table, that gives me n, or my overall table total, which in this case is 1808. So the first question says, what is the marginal distribution for grade average? So the variable I'm looking at is grade average, and we can see what the different categories for grade average are. There's A's and B's, C's, D's, and F's. So we're basically, when we're finding a marginal distribution, we're basically just finding the percents for each of those three different categories. So I'm going to write those down. So I have A's and B's, C's, and D's and F's. When we're finding marginal distributions, our denominator is always n, the overall table total. And our numerator is going to be either the row or column total that's associated with the category that we're looking at. In this case, the variable we're looking at is in the columns here. So I'm going to be using these column totals as my numerators for calculating the percents of this marginal distribution. So for the first one, A's and B's, there was 941 students that received A's and B's out of 1808 total. So that gives me a value of 0.5205, or 52.05%. The second one, for C's, there was 594. So I'm going to have 594 over 1808. Should have left myself a little bit more room here. That's going to be 0.3285. or 32.85%. And D's and F's, total D's and F's, there was 273 divided by 1808. So that gives us 0.1510, or 15.10%. So your percentages in a marginal distribution, if you calculate all of them, they should add up to 100%. Relatively 100%. There could be a little bit of rounding error, as you saw in one of your quiz questions, but essentially they add up to 100%. So that's our marginal distribution. We could also find a marginal distribution for the other variable in our table, which is whether or not they played computer games. So to do that, I would use these row totals and put those over n. So the next question wants to know what percent of kids who played games got A's and B's. So now we're looking at the relationship between these two variables, the grade average and whether or not they played video games. And so this is going to be a conditional distribution. And one of the key things to look for when trying to figure out conditional distribution problems is this word of. Okay, so whatever follows the of is what we're conditioning on. So in this case, we want to know what percent of kids who played games got A's and B's. So I'm conditioning on kids who played games, meaning I'm basically blocking off this portion of the table and only looking at these values here. And when I flipped screens, I lost all my totals, so I'm going to go ahead and hurry and write those in so we can have those handy. This is just the row and column totals that we calculated on the last page. All right, so I want to know what percent of kids who played games got A's and B's. When I'm looking at a conditional proportion, then my denominator is going to be a row or column total, depending on what we're looking at, and my numerator is going to be one of the values from a cell in the table. So in this case, I'm looking at kids who played video games and got A's and B's, so that number is 736. That's going to be in my numerator. And I'm only looking at the people who played games, so my denominator is 1379. So if I take 736 divided by 1379, I get 0.5337, or 53.37%. Next question says, what percent of, remember that's our keyword, of kids who never played games got A's and B's? So that would be kids who never played games. We're blocking off those guys. We're conditioning on that. That means my denominator is going to be that total for the row that we're conditioning on, so 429. And we're interested in the kids that got A's and B's, so we're going to use the number for that, which is 205. So if I take 205 divided by 429, I get 0.4778, or 47.78%. All right, so one more, just to kind of illustrate the difference of how we'd find these things. Let's say we wanted to know, and I'll see if I can write it up here, what percent of kids who got A's and B's played video games? So what if I said, what percent of kids with A's and B's what percent of kids with A's and B's played video games? Okay, so just kind of recognizing the difference between this question and the first question that we asked here. So, in fact, I think I'm going to change my pen color here. Pen ink color. Switch it to blue so we don't get confused. All right, so now I'm still looking at that keyword of. This time I'm looking at of kids with A's and B's. So I'm conditioning on people who got A's and B's. So if I'm blocking that off in my table here, I'm looking at just the kids who got A's and B's. So that means that my denominator for this proportion is 941. And my numerator is going to be the number of kids with A's and B's who played video games. So that's this 736. So you can see it's the same numerator here, but different denominator depending on what we're conditioning on. So if I take that 736 divided by 941, I didn't do that one ahead of time, so let me pull out my calculator, see if I can figure that out real quick. So I have 736 divided by 941, then I get 0.782. 0.782, okay, or 78.2%. So hopefully that illustrates the difference in how exactly you find a conditional distribution. Last question on this slide, does this mean that playing video games causes kids to get better grade? And hopefully you recognize that a red flag in this sentence here is the word causes. The only way to be able to say that something causes something else is if we did a designed experiment in order to find that out. So in this case, there was no experiment. They just found a bunch of kids. They said, hey, have you played video games? Also, what kind of grades did you get? So it was an observational study. So because it's an observational study, we can't show cause and effect. So we would have to design some kind of study where we took a whole bunch of kids and we said, we gave half of them an Xbox and the other half, we took away any video games that they ever had and we let them kind of go at it for a few years and we looked at their grade point average, something like that. So be very cautious every time you see the word cause and make sure that if you're using the word cause, that it can be used because it was an experiment and not an observational study, which was not the case this time.